Now we see the example for Banker's algorithm. So consider that a system with 5 threads T0 to T4 and 3 resources A, B, C. So the resource A having the 10 instances, B having the 5 instances, C having the 7 instances. And the current state of the system is this one. So this has been already allocated to each resources the maximum requirement of each thread and the remaining available resources. So from that we need to calculate the need matrix. So already we know that the need is equal to, so formula for calculating the need is equal to that maximum requirement minus already allocated. Okay, so we calculate that need for each thread. Okay, so for T0 the need is, if you subtract maximum minus allocation, this is equal to 7, 4, 3. This is for T0. For T1 it is 1, 2, 2. You subtract this 2. Okay, 3 minus 2 is 1, 2 minus 0, 2. This 2 minus 0 again 2. Then for T2 it is 6, 0, 0, like that. For T3 0, 1, 1. For T4 it is 4, 3, 1. So it is T1, T2, for T3 and T4. Okay. Now we need to find the safe sequence. Okay. Now we go with the safe sequence. First take the resource T0. This is thread T0. So the currently available is 3, 3, 2. The T0 needs 743, 7 instance of A, 4 instance of resource B, 3 instance of resource B. So as of now, we cannot allocate the resource to the thread T0. So T0 will be in a waiting state. Now go with the T1. The current need of the T1 is 1, 2, 2. I mean 1 instance of resource A, 2 instance of resource B, 2 instance of resource C. So the available is 3, 2, 2. So it can be allocated. So T1 start its execution and completes. After now T1 completes. After T1 completes, this 2 resources also has been released with that allocated resource. So the available will become 5, 3, 2. Okay. After T1 complete its execution. Okay. Now go with the T2. This is the available. The need of the T2 is 600. It cannot be allocated because it needs 6 instance of A, but we have only the 5 instance of A. So T2 should be in a waiting state. Next go with T3. The T3 need 011. We have the 532. So it can be allocated. So the T3 starts its execution. After T3 complete its execution, this resources also should be added with this. So we have a 7, 4, 3. After T3 completes the execution. Okay. Now go with the T4. The T4 need 4 instance of A, 3 instance of B, 1 instance of C. We have that enough availability. Okay. So T4 can start its execution. After T4 complete its execution, this resources has been released with the currently allocated. So 7, 4, 5. This is the available resource after T4 complete its execution. Now, what are all the remaining threads needs to complete? T3 has been completed. We have completed T4 also. Now go with again the next cycle, again go for T0. Okay, the currently available is 745. The T0 needs 743. So we can allocate. So T0 can start its execution. Once T0 complete its execution, this threads also comes into the available 7. 7, 5, 5. Okay. Now the remaining T0 also complete its execution. The remaining is T2. The current need of the T2 is 600. Okay. So we need to start the execution of T2. Okay. So once T2 complete its execution, it release T0 to it should be added with here. So 10, 5 plus 2, 7. So these many resources will be available after T2 complete its execution. So in the last, the available resource after executing all the threads should be equal to the starting available, instances. So 10 instance of A and 5 instance of B, 7 instance of C. So all the thread has completed its execution. So it means that the system is in a safe state. This is the safe sequence. There is no deadlock here. Okay. Now consider the same problem with T1 have requested one instance of A, 0 instance of B and C, 2 instance of C. These many more instances T2 has been requested. For that I have given the allocation matrix and need matrix also unavailable. Now we go with the directly the safe state, safe sequence. Okay. T0 cannot start its execution as T0 needs these many instances, resources, but that is not available. Then we go for a T1. Okay. So the available requested resources available. T1 can start its needed resources available. So T1 can start its execution. After T1 complete the execution, that available resource becomes, so available resource will become 5, 3 and 2. Go to T2. As T2 request 6 instance of A, only 5 instance of A is available. We cannot uh, T2 allocate that resource to T2. So go with T3, check the need. So it is 0, 1, 1. Definitely we have a 532. So T3 can start its execution. After T3 completes, these resources also need to be added. So 7, 4, 3 is available. Okay, T3 also complete its execution. Go with the T4. The available resources 4, needed resources 4, 3, 1 for T4. It is available. So T4 can start its execution. After execution, it release the resources which has been allocated now with already allocated. So there it will become 5 after T4 complete its execution. Now go with the T0 again. Now check whether T0 can start its execution. Yeah, the available resources are, the needed resources are available. So the T0 start its execution. After T0 complete its execution, so the 7, 5, 5 will be available. Then go with the T2. Then T2 start its execution. So and it completes. Okay. So this is the safe sequence. Thank you.